Okay, so now we're going to continue with the next video. By the way, just real quick, if you didn't know already, you can put in your absolute value of x. You do this button, which is to the right of the 9, that button, and there's the absolute value x. Since there's only one interval, you can't use the piecewise function and limit it, so you kind of have to do it this way, where that's the absolute value of x, and then you hit Control T to get to your table, and then at -1 it's 1, 0, 0, 1, 1, 2, 2, so forth, and you have more information in the table than what's actually valid, and so you just care about from -1 to 2. Now notice when we're showing the table, it looks like a vertical stretch, so to speak, but that's just because of the scale factor, because when I go to get rid of the table, it's back to like the 45-degree angle. So those are just some tidbits on the graph, and now we're on to 17. Okay, so 17 has 2 conditions instead of 1, and so this one will be a little interesting. We're going to start with g of x equal to negative x when 0 is less than x less than 1, but x minus 1 when 1 is less than or equal to x less than or equal to 2. So let's go ahead and try putting this in the calculator. So to start with, we're going to press this button, and we need the one with 2 conditions and 2 expressions, so that's the 2 by 2, so to speak. And first we have negative x, and then we have x minus 1. Okay, those are the 2 functions, and then we need 0. Remember, for inequalities you have to use the Control equal button, and then it brings up a pop-up, and we want less than or equal to x, and then we just want less than 1. And then on this one we want 1 less than or equal to x less than or equal to 2. Okay, so that's what it looks like. You don't have any extra pieces, just those parts. So based on that, let's graph on paper. And at 1, it was -1 as a whole. And this just goes straight down. And then at +1, it goes up to 2. Well, at 2, 1. So that's what our graph looks like. Again, remember, if you look in your table, for the F1, which is the negative x, it's going to show that it's undefined for certain parts. But 0, 0 is a point, 1, 0 is a point, and 2, 1. Of course, there's no other thing for F2 because we only used F1. So you hit escape and then go back over. And it even labels it piecewise. So again, notice 1 is 0, and it's approaching this one. And again, back as a reminder, this would be where the limit does not exist, because from the left, it would be equal to -1, and from the right it would be equal to 0. So the limit does not exist. Okay, so what we have for this one is it has an absolute maximum right there. So f has an absolute max at x equal 2, but does not have an absolute min. F has an absolute max at x equal 2, but not an absolute min. So it's not continuous. At x equal 1. So we don't meet the conditions. It's not continuous at x equal 1. Again, we have a jump discontinuity, so we don't meet the conditions of it being continuous. Okay, number 19. This one, we just have y equal 3 sine x. Well, you may know from trig, when we looked at this before, that we could say it goes from 3 to negative 3, and since it's a sine graph, it kind of goes like this. But what we really want is 0 less than x less than 2 pi. So again, you can change your table to be that, or just think about 1 period worth, which would be this part. And so I'm going to darken this. And that's going to be it. So this is from 0 to 2 pi, because remember your period is t, which is 2 pi. Okay, by the way, one other quick note. What we could have done on 15, same thing I'm going to show now. So we could have put in 3 sine x, and we can't type a condition, but what we can do is change your window, either through double clicking or just go menu, window, and talk about putting 0 to 2 pi like that. And so there's what it looks like. 0 to 2 pi. So if you ever want to, if it only has one condition, it's not a piecewise, but you could just set your window appropriately. So that's what we're looking at, and this is the max, that's the min. Okay, so f has an absolute max. So the way this works is, if this is 0 and this is 2 pi, then the middle is here, which is pi. And then the middle of this would be pi halves, comma 3. And so in the same way, this would be 3 pi halves, but then negative 3, because the middle of pi and 2 pi is 3 pi halves. So we put f has an absolute max at x equal pi halves and an absolute min at x equal 3 pi halves. The problem is that this doesn't say less than or equal to, And so 0 to pi is an open interval. It's just another form of this with inequalities, and this with parentheses. So this is an open interval, so we do not meet the conditions. F has an absolute max at x equal pi halves and an absolute min at x equal 3 pi halves. 0 to pi is an open interval, so we do not meet the conditions. Again, to remind you, you can go to Analyze Graph and then maximum is 3. And lower bound just means the left side and then the right side. Now, this 1.57 would need to be turned into a, number. Pi would be this, and so if we did pi divided by 2, we can compare it, and that matches. So we need the exact value. Need the exact value. Don't put 1.57 there. So just as a little note, need the exact value, not 1.57 or 4.71, which is what 3 pi over 2 is. Just going to do a shortcut. Okay, so I took it times 3 is 4.71, and if I go back to where I was and do my minimum between here and here, that's the 4.71. Again, I'm showing many decimal places, but it doesn't really stop at the 104. We don't even see the 104 here because of rounding. So anyway, let's not get hung up on that, but the main thing is we need our exact answer. Okay, so that's number 19. Number 21. So these instructions say in exercises 21 to 36, find the absolute max and min on each function, then graph it, identify the points on the graph where it occurs, and include their coordinates. So that means we're going to need both x and y values. So for 21, we have f of x equal 2/3 x minus 5, and it's negative 2 less than or equal to x less than or equal to 3. Just as a quick side note, this is inequality notation. Inequality notation is when you have your less than symbol or less than or equal to, and then interval notations where you have brackets or parentheses. So just as a quick review about that, now what we need is to graph it. This is just a linear function. We know our slope is 2/3. Our y-intercept's negative 5, so that means it goes through 0, negative 5. If you want to use your calculator to graph this, you can, but remember in college algebra and on other tests, sometimes you may have to not use the calculator. So we always start with the y-intercept. 1, 2, 3, 4, 5. So this is negative 5. Put a dot. And this is rise 2 and run 3. So 1, 2, 3. Okay, so we go 1, 2, and then 1, 2, 3. And it does include those points. Let's see, 3 is the ending. And it should go all the way to -2. Just continue it like that. So that's how I sketched it by hand. Of course, if you wanted to go again to doc, and then we want to do new document, and add graph. This is where, remember, you had the y equal button, but now it's F1. So you say F1 of x equal 2/3 x minus 5. Again, just as a reminder for those that have the other form of the calculator, put parentheses around your 2/3. On the CX2s that we use, it automatically did it right, and you can check it. But that's our graph. And again, we go to Control T to look at the table, and these are the points we want. So I'm going to first write some really good points. What I mean by good in this case is ones that are not decimals. And at -2, that's an endpoint. Actually, we need that, I think. So -2 is -6.3 repeat. Let's see. Are there any good points? 0, -5. And 3, -3. By the way, just as a reminder, if you go to something like that, which we know has infinite decimal places, you can do Control-C to copy it, like you do in computer applications, and then Control-V to paste it. And at this point, I'm just going to try to convert it to a fraction. I might need to put extra 3s. I usually go to half the screen, but let's just try it. Okay, it liked it. So -19/3. Just ignore this 5e to the -14, because anytime it's e to a negative number, that'd be like 0. So this is -19/3. Okay. So what we have on this is there's no critical points. There's no critical points. F of 2 equal -19/3. F of 3 equal -3. And then we have an absolute max. At x equal 3 is -3. So remember, this is the y value part of it. The -3 is the y value. And let me change the wording of this. The absolute minimum is -19/3 at x equal -2. So just as a reminder, this would be the y value, and of course that's the x value. So sometimes on problems they want the x value first, and sometimes they want the y value. Just pay attention to where if it said x equal, or if it wanted the y value first. So those are the two variations of the problem. Okay, so that's 21. 23. Okay, so again, what you have to have, I mean, probably the whole thing, but yeah, that. The table would be helpful, but I know sometimes y'all use your calculator for that. But again, we needed the exact value, and don't round it to a decimal. That'd be frustrating if it would count negative 6.3 wrong. That's why you have to change it to the exact value. Okay, 23. This one we have f of x equal x squared minus 1, negative 1 less than or equal to x less than or equal to 2. So on this one, we know in general that it'd be a parabola that starts at negative 1. It's going to go up a little bit, and then just like that. And these are solid dots. And we know that if we plug 2 in, 4 minus 1 is 3. And if we plug 0 in, it's negative 1. And if we plug in negative 1, just remember that's equal to 0. You would have to have parentheses around it. So that's your values. So you definitely need your graph. I don't want to take too long on this, but some people may think incorrectly that it's negative 2, but this is indeed right. And if we go x squared minus 1, and then go to your table, at negative 1, it is 0. At 0, it's negative 1, and at 2, it's 3. Okay. So there's that part, and now we need our description. So f prime of x, which means the first derivative of x, would be 2x. Remember what we do is we take our exponent, bring it down, and decrease the power. So we get f prime is equal to 2x. And that would lead to the conclusion there's a critical point at x equals 0. And then the other things we need are f of negative 1 equals 0, f of 0 equal negative 1, f of 2 equal 3. And then we have the absolute max is 3. At x equal 2, which by the way means 2, 3, like we've said before, and the absolute min is negative 1 at x equals 0. So again, 0, negative 1. In Math Excel, it's not going to want the ordered pair, but I'm just doing that for understanding purposes. So there's your information for 23. Okay, 25. This time they have a capital F. It doesn't really matter, but capital F of x equal negative 1 over x squared, and they have 0.5 less than or equal to x less than or equal to 2. So first we want to graph this. Again, just as a reminder, sometimes they just change a certain number on it. So just look how that works out. So there's your negative 1 over x squared, which basically means both sides are down. Okay, so there's your negative 1 over x squared. What I'm going to do is put in my 0.5 my half and my 2. And so it's going to look like that, which looks pretty different than what it was before. But now we're just limited to this interval. So that's what we want. So 25. Notice our scale is very, very different. This is from 0.5 to 2, but it's got so many tick marks. So we actually may be better off just changing that back. That does look quite different. So let's change our window back to the standard window, because this is going to be more realistic. We just have to keep that in mind, because we know our graph is going to end up going like that, and then we can use our table. You all know how to use your table, and you'd find 0.5 comma negative 4. That'll be your absolute minimum, and this point, it's not on the x-axis, but it's just there, and it's 2 comma negative 0.25. That's your absolute max. So that's going to be our graph. Now mine is more rounded. You could do it more like this if you want to, or to be perfect, it would be like that. If you actually do it to scale. But anyway. Okay, so what we have is your f of x equal to negative 1 over x squared. Remember, that means negative x to the negative 2. That's how we rewrote it. And then when we take our derivative, we bring our power down, and it'll be negative times negative 2, which is positive 2, and then x, and then decrease by 1. So this would look like 2 over x cubed. So that's what our derivative is. But notice that at x equals 0, it's undefined. X equals 0 is not a critical point, since 0 is not in the domain. And then as far as the other things, f of 0.5 equal negative 4, f of 2 equal negative 0.25, And then just the wording, the absolute max is the y value negative 0.25 at x equal 2, and the absolute min is the y value negative 4 at x equals 0.5. So yeah, on this one you pretty much need the whole thing. So you have f of x, which is really rewritten to be negative x to the negative 2. We bring our exponent down when we're taking the derivative, and so this turns into positive 2 x to the negative 3, which is like 2 over x cubed. And 0 would not be a critical point in this case because 0 is not in your domain. So you just look up here, it's not in your domain. And then the other stuff is self-explanatory. Okay, number 27. Okay, on this one we have h of x equal to the cube root of x. By the way, we can go ahead and write that as x to the 1/3. The 1 comes from there, the understood power. And our interval in this case is -1 less than or equal to x less than or equal to 8. So here 0 is in the interval. And first thing we're going to do is graph it. And then the cube root of x basically looks like that. And then we just need a little bit here because at -1, it's -1. And over here at 8, it's 2, because the cube root of 8 is 2. And y'all already know how to do this on your calculator. Just look in your table or plug in your values. So this is going to be your absolute max. This is your absolute min. So then as far as our description, well, we need to do our derivative first. Whoops. I'm trying to go a little bit too fast. 1/3 x to the, here I'll take a step, putting in parentheses, 1/3 minus 1. So this is 1/3 x to the -2/3. So again, we're decreasing a power by a whole number. So we're doing it by -1 in this case. And so you do have a critical point at x equals 0. That's where it's changing direction. So you have a critical point at x equals 0. You have h of -1 equal -1, h of 0 is 0, and h of 8 equal 2. And then the absolute max is 2 at x equal 8, and absolute min is -1 at x equal -1. Okay, that's going to be a good stopping point for the video.